Hello and welcome. Good morning. I am Tejas Kalsasi. I am giving this quick demo on how Apache Spark works and how it is working, how the project output is coming. So, this is the terminal for running Apache Spark, and we will be giving a Spark submit query. But before that, I want to give a bit of a background. So we are using Apache Spark 2.4.3, that is one before the latest version. The latest version is 2.4.4, but there is a new version in the pipeline which will be coming in ahead in December called as Spark 3.0. So this is what is used currently in the industry standard because this is the stable version and offers all the latest features of Apache Spark. And this is the home directory where the Spark and Hadoop are stored. uh, this is the home directory for the project that I have completed, and so we will directly move on to the Apache terminal. So here we will start the server by using the command spark submit and server dot py. So the server file contains the uh, useful information about initializing and training the system. To train the system, we are using the default movie lens database, and that is publicly available for use. uh, in this application we have made use of PySpark, and we have also used the Flask framework for Python, that is for the micro that is a micro web framework which uses roots. This is very much similar to REST API or RESTful services, and by using get and post methods of HTTP we can easily access the information from the Spark, and we can get the output. So this is the app.py which is run, and it will be receiving the request from the terminal or from the browser, and we will get this is the controller of the program, so it will call the function and get the recommendations, whereas these are some sample methods that I have created in the text file. So these are some sample outputs which I have been getting for the past few tests that I have run. So the server is coming up, and we can this can be observed by our Spark this master server. So this is what we have: one worker node. The total memory is 14 gigs. That is the complete memory of this laptop, and there is one application that is running. So this is the previous one, but now we will click on the new one. We will actually open this in a new window. That way we will get more information on both the worker and the application. So we are getting, yeah, we are, this is how it is currently showing us, and it is training and initializing the system. So we can see that information from the terminal as well. This is the second terminal. The first terminal has the information that is running. So when this system is initialized and uh, running, the it serves on this HTTP, that is 0.0.5432, this port. So this is the server that is up by CherryPy. So CherryPy is another Python framework for quickly initializing a web server and getting the data back from the app or whatever the medium is, the database or whatever it is. So here the terminal is running, and I think it will take about another 2 minutes probably to complete this task, as we are in stage 25. So yeah, I think the cherry pie is set up and it is running on this server. So here our server is up and running. You have landed on the home page. So this output is come from the route that we have established, that is this route that you have landed. So when by using such routes, we are able to get query and get the information from the server, from the Spark as well. So this is giving the string output and it returns, whereas over here when we use the specific methods that we have defined, we get the output. So for output purpose right now, what we are going to do is we are going to get the top 5 recommendations for a user. So here the context is that the user ID is 20 and we are getting how many recommendations, that is 5. So when we post this in the terminal, or we can actually also post it over here, but it won't return anything here because we haven't initialized it that way in the app, that is in the routes. Currently I have been getting the returns in in the terminal, that's why it is returning the JSON file. So but we can also convert that into string or into HTML and give the output in the web browser. But for now we will get the top 5 ratings for user number 20. And when we click this, CURL is the uh, tool that Linux we can use in the Linux shell to get the output. So as soon as we click on that, we there is a new task that is created here, active job 1, and that is to get the order, the query that is for the top 5 movies, for top 5 recommendation for user number 20. So it will run the Spark is Spark ML in this case is run, and it will, as it is shown here, that the executors and the job, a job is created for that, and it is currently active, and that also can be seen in the terminal that is running over here. So it is updating the RDDs, and it is getting the recommendations. So this terminal is running in the background, but as soon as it processes that information, it gives the output, and the output is given, and we can see on the other terminal where we send the query that we get the output here. As we can see, for user number 20 we are getting the output. This works on the processes of matrix factorization and least squares alternating least squares. So once we get the output, we can actually this output is in form of JSON file. We can also show that in the web browser. Another method that we have defined is the post, that is to post the user uh, reviews. So for a new user, let's say we have completed that as well. So for, let's say, for a new user, here we will copy this as of now, In this, the user number is 20, and here the movie ID and the ratings is given over here. So we will change this because this is already there, and we will be typing over here as, let's say, oh, okay, it is, yeah, now we can, let's say, for user number 15, and the ratings for the movie ID 100 will be, let's say, 8. So when we post this entry is being logged into the CSV file, and it will train the model for this particular user. So that can be seen over here. It will create a new task in the Apache Spark, and the task will be executed, and it will retrain the model. And when we ask for the recommendation for user number 8, we will be able to see a difference. So in the meanwhile, what we can do is that we can get we can uh, see the recommendations for this user, that is the user over here, the user number 15. So right now we will what we will experiment that we are doing is that these are the user number 15 is our current test subject. So we are copying this, and this shows that we have input that for movie ID 100, the person is giving rating as 8. So after this, what we are going to do is we are going to we are going to add another entry, and we will give another rating for another movie. So what we will do here is, this is for user ID 15. We have given the movie ID 100 8 ratings, and now we will see the top 5, or actually top 10 recommendations. So we will query that for this user, and then again we will give another rating later, and that way we can figure out what how the system is working. Let's say movie ID, uh, let's say 30, and the rating will be 5 for the same user. So that way we will be able to get and see the different output. So here what we are doing is we are fetching the top 10 for user ID 15, and then again we are going to fetch that after this, and we will see the difference. So when we post a rating, we always see in the output is okay, that is here. So we will see that 15 for user ID 15 and movie ID 100, the user has given 8.0 rating. And now what we will do is we will ask for recommendations for, oh, sorry, CURL. We have to get get or actually we can directly get it. So we can use the get command, where this is automatically getting the top 10 for user ID 15. CURL here, and As you can see, there will be a new task that will be created over here. Yeah, it is taken the order, take ordered, and it will give the recommendation based on this. So let's go to the terminal. Over here we will get the JSON output in terms of what the top 10 movies are for this particular user. We can also send a complete file, or a collection of ratings for a particular user by giving it a data file. So here we are, we have got the response, and we are going to copy these and save it in our text file, that this is the output for top 10 for based on the reviews. And now we are going to post a new rating, and we will see what change we get in the ratings. So for movie, over here for user number 15, he is giving movie ID 30 a 5 rating, which is a lower rating. So we will now post it, and a new job will be created here that is running. We will just quickly refresh. So because this is a single node standalone cluster, we are we have to it is taking a little bit of a delay, and it is using 4 cores, and this is the IP address of my current Wi-Fi, that is location. So this is how it is running, and let's refresh. It takes a while sometimes, maybe a minute or two sometimes, to post a rating and retrain the model. So as we see here that we are currently it is working on it. Okay, so stage one is over. Now it will work and get the next stage done. So here we have the event timeline that is, it gives us a whole picture of how it is from the start, which tasks were given. Let's refresh. So this is a new approach. The a previous approach that I was using a Hadoop based approach by creating a Hadoop file system and then working through there. But I found that to be a bit tedious, and the new Spark supports a couple of new methods to directly use different files directly from the system. We don't need Hadoop. That is why this is okay. So this is done over here. Yeah, we got the output. So now we will again get the we'll get the ratings, top 10 ratings for user number 15, and a new task will be created here as usual. Active task is 1. Probably this will be a bit faster because the system already knows about how the user is, the model is already trained a couple of times, so probably it will be a little faster, although I can see that there are a lot of stages here. So Let's wait for the output. So as we are okay, here we are. We have got the output here. And let's copy this, and we will see if there is a difference. Probably there should be a small difference in terms of the movies. So as you can see, there is Planet Earth 2, then there is Planet Earth, then there is here the Band of Brothers that used to be in the third position, but that has been shifted down, and we can see the in the new ratings that Cosmos is a new movie that is recommended him at the third position. And then we have the Band of Brothers over here. So as we can see, this was the previous one. In our previous get command, the Band of Brothers was on the third position, but it has swapped with the next one, that is Cosmos, based on the matrix factorization. And after Cosmos, on fifth position was Planet Blue, but that also has been replaced by this movie. And as we can see, the previous ones have been pushed further behind. uh, Here Shawshank Redemption is coming. This was last over here, but this is now a couple of places above, as we can see here. So yeah, the Blue Planet is at the last here, whereas it was on the seventh. So we can definitely see that there are changes in this recommendation, and for this particular user, that is user ID 15. And the based on the ratings of the movies that he gives and the movies that he watches and the ratings that he gives for those particular movies, he will be given the particular recommendations based on this. So this is uh, a quick demo that I wanted to present today. Thank you so much for watching, and I hope this was a good presentation, and I hope this was useful. And please give me the next updates on what we can go ahead and do with it for regarding the submission. Thank you so much. Thank you so much for your time, and have a great day ahead.